Okay. You see whiteboard, right?
Yes.
So number 11. Number 11 is super easy because in both equations, the y variable is isolated. Entonces, super easy. Put equal each other. Equation 1, equation 2. The first one is non-linear, the second is linear. You put equal each other. Entonces, 6x squared minus 5x is equal to x plus 3. Now, I suppose it look like quadratic equation. Entonces, I organize in this way. X squared minus 5x minus 2x minus 3 equals 0. So we combine like turn is 6x squared minus 7x minus 3 equal to 0. We can solving this quadratic equation using the quadratic formula or by factorization. Either way. I did by factorization. I don't know why. Look, you multiply this guy and this guy together without sign, it's 18. And the combination can open the door for this factorization is 9 and 2. Because 9 times 2 is 18 and 9 minus 2 is 7. You split 7 using 9 and 2. Entonces 6x squared minus 9x plus 2x minus 3 equals 0. Then that part and that part you factorization separately. This is the common factor is 3x. We have 2x minus 3. And here the common factor is 1 because it's nothing. 2x minus 3. Then 2x minus 3 is a common factor. And we have another factor that is 3x plus 1. Guys, either way, the way you prefer. Some people could prefer quadratic formula, it doesn't matter. Therefore, we have 2x minus 3 equals 0, then equals 0, equals 0, then x alone is 3 over 2 positive. And another is 3x plus 1 equals 0 is x equal negative 1/3. So far it's okay. Everyone follow me? Yes or no? Then substitution, of course, the easier equation, que in my opinion is the number 2 equation, que is linear. In order to find the y associated with this is 2 times 3 over 2 plus 3. This is, you cancel out the 3, plus 3. You cancel out that 2, and stay 3 plus 3 gets 6. Entonces the point is a point, 3/2, comma 6. Okay, using another value, y is equal to 2 times negative 1/3 plus 3. This is negative 2/3. Multiplication fraction, 2 times 1, 2 times negative 1, negative 2/3 plus 3. 3 is a whole number, therefore is LCD is 3 and negative 2 plus 9. Because 3 times 3 is 9, so it's 7 over 3. And the point are negative 1/3, comma 7 over 3. Okay, the option A in the review package. Let me try to see. Yeah, 2 solutions. 3/2, comma 6, negative 1/3, comma 7 over 3. Super easy. Any question? No? Everything okay? Let's do it number 12. Number 12 is the equation R 3x squared minus 3y squared equal 36. Equation 1, nonlinear. And the second equation is 4x squared plus 5y squared equal 84. Okay, I see clear. Okay, equation number 1, I can divide it by 3 because every coefficient is divisible by 3. Therefore, it's easier to write this equation, x squared minus y squared equal 12. And this is my equation 1 after the simplification. And also, I want to pay my attention in this equation, 1 and 2, after the simplification. Then it's obvious that if both equations are non-linear, you need to apply elimination. And elimination, I propose you multiply the equation 1 by 5. What is the objective? What is the goal? The goal is to have negative 5y squared and positive 5y squared ready for elimination. So I copy one more time the equation 1 after the multiplication by 5 is 5x squared minus 5y squared equals 60. 60 was the multiplication 5 and 12. For a moment, I forgot this. I focus in this and this together. Then this is 9x squared. And this is 144, que es 84 plus 60. Finally, divided by 9 both sides. And take out square root. 144 divided by 9, square root both sides. X alone is equal plus or minus 12 over 3. Okay, 4. Plus or minus 4. Well, good. Now, in this case, as any equation, okay, I come back to the easier equation, okay, number 1 after the multiplication by 5 is this equation. I take this equation, I plug in, look, I plug in x equal plus or minus. I can do in both. Why? Because when you square become positive. Entonces this is 16. Positive 16, it doesn't matter if it's positive or negative. Minus y squared equal 12. Therefore, 16 minus 12 is equal y squared. This is 4 is equal y squared. Apply square root both sides. So y is plus or minus 2. This is obvious that we have 4 solutions. In the combination, okay, the combination positive 4, negative 4, and positive 4, negative 4. And we get positive 2, negative 2, and positive, negative 2 here, and positive 2 here. Yeah, get the option C. Option C. Number 12, option C. Look at that, 4 solutions. 4 solutions. Press la que order pair. 4 solutions. C option. Cool. Any question? Easy, huh? No comment. Everything okay? Do you follow me? So good. Okay. Number 13. No. 13 is x squared. 13 is easier. x squared plus y squared equal 4, equal 9, sorry, equation 1. And x squared minus y squared equal 9. This is my system, non-linear. But this is because it's ready for elimination. So you add equation 1 plus equation 2, you have 2x squared. That part's cancelled. And this is 18 divided by 2 and 9. When you apply square root, plus or minus 3. And when you substitute in either equation, I substitute in the first one. I don't know why, but you can do it in any equation. You substitute both because it's a square and become positive. We get the same answer. Plus y squared equal 9. And it's a 9 plus y squared equal 9. It's obviously y squared is 0 and y is 0. And 0 have no sign. 0 is 0. We have two solutions only, que es 3,0 and negative 3,0. End story. Option B, I guess so. Let me see. Oh, yes. No, B. Let me see. SA option. SA, no B. I make a mistake here. SA. Look here. Option A. Okay, SA. Oh, yeah, I see. Yes. Cool. Okay. Next question is inequality. And inequality is graphically. And the graphic always we are doing in decimals. Okay, let me try to share decimals. And you see that. So you see the line, remember the idea, and decimal is super easy. Let me show you. Okay, it's a question 15, no? 15. Okay. 15. Okay, cool. 15. Look, 15 is this. Do you see decimals? Entonces, super easy. You put it in inequality, connecting by and. And remember the connection by and is using, but no, it's not. It's not like that, no? It's 14. F14. You're right. Yeah, F14. F14. Just copy. No. By hand it's complicated. You need to solve for y, and you see it below or above. But in this one, no. And then when you put the inequality separated by a curly bracket, then understand very well that this is and find the intersection between two regions, and you see. In this case, both are solid line. I don't know why I don't put solid line here. It's okay. This is the solution. You copy and you make a screenshot and you attach in the test. Suppose you have one similar question like that. Okay. Similar idea we are doing in 15 and 16. Let me try 15 and 16. 15 is, look, is x squared plus y squared less than or equal 100. It's a circle. And the line 2x plus 7y less than or equal 14 together is this. Wow. It's inside the circle and below the line. This is 15. Do you follow me? Yes or no? Clear? Confusing? Clear, okay. Likewise, 16 is another circle and a line. Look. It's similar. 16 is similar. Okay, no problem, right? Just clear. Okay, 17 and 18 is the classical linear programming problems. Let's do in 17. 17, remember linear programming problem contain constraints. In this case, we have 3 constraints. Okay, it's x in between 0 and 10, y in between 0 and 5. This is a rectangular. And 3x plus 2y greater than or equal to 6 is a line, no? It's a line. Entonces, you form a polygon. This is a polygon. Actually, the polygon is, I don't know why, in my Desmos doesn't accept this separately. Here, this is the rectangular in the first constraint. And it's, pero esa es above line. Entonces, basically, is this pentagon, no? 1, 2, 3, 4, and 5 side. And a corner is easy to determine, que es 0,3, 0,3, 0,5, 10,5, and 10,0, and 2,0. That's okay, okay. Entonces I want to continue this part in the not necessary. Let me see. Yeah, well, let me see. Let me continue. Let me make a screenshot to these pictures. Okay. A screenshot. Save. Okay. Here, over there. Save. Okay, let's come back to the whiteboard. Ow, carajo. I close the Desmos. Not good. I need to open again. Okay, close this. I share the whiteboard. Try to bring the image I save. Okay, where is this? I don't know. Well, actually, the pentagon we see in Desmos look like that. This is the feasible region. And this corner is 0,5. And this corner is 0,3. And this corner is 2,0. That one is 10,0. And that one is 10,5. Okay, and this is my feasible region. Let me using that color. Same color. Entonces the problem say find the maximum of the objective function, and you evaluate this corner one by one. And the objective function equation was 15x plus 13y, no? And you evaluate one by one. Suppose you evaluate in 2,0. Here, that corner first. I rotate around the pentagon and counterclockwise. So, okay. And you evaluate 15 times 2, because this is x value, this is y value, plus 13 times 0. Let's solve the 30. This is the objective function evaluating this corner. Now evaluating the next corner, que is 10,0. The order is not important. Either order. I select here number 2. Is 15 times 10 plus 13 times 0 is 150. Okay, better. 150 is better than 30, no? Because it's maximum. And C evaluate in 10,5 is 15 times 10 plus 13 times 5. The 150, this is 65, I guess so. Together is 250. Okay, now C evaluate at the point like that. We need more points. Number 4 and number 5, pentagon. Okay, and 0, 5. 0, 5. 15 times 0, because x is 0, plus 13 times 5. Okay, 65. Now, okay. Now, the last point is C evaluate and 0,3. Okay, 15 times 0 plus 13 times 3. Okay, 39. Well, it's obvious. Okay, this is the maximum. So the maximum of Z is equal to 15. But it's important to say is add x equal 10 and y equal 5. And the story is that point. Any question? Do you understand very well this or no? Okay, everybody say yes. Okay, guys, remember this is review. Any minimum question you have, let me know. I try to explain. The most important is that you are doing well in the test. By the way, I don't remember. I sent the test or no? I sent, right? Yes. And when it was planning the due date for this test next Monday, no? What's the due date? Okay, Tuesday, I say yes. Okay, by the way, next Monday is 5th, no? December 5th. Yeah. Okay. Okay. So now 18 problem is similar, very, very, very similar. Let me try to do better now. I go to the Desmos, but I delete Desmos. Wow, amazing. I need to open another window. Okay, I try to find Desmos. Okay. Yeah, hello, what the hell? Feature registers. There you go. It's in my account. Okay, now. Wow. It's Mac 1106. Review for the test 4. There you go. Okay, cool. Now we are doing the question 18 is the last one. Well, the last one graphically. Okay. And the linear programming problem 18 have 1, 2, 3, 4 constraints. Wow. And the 4 constraints are, look, Look, x positive, so non-negative, y non-negative. This is the first two constraints, the first quadrant. We have a line, and we have another line. And you find the corner. The corner is easy to find because, for example, to find that corner, you intersecting, you convert this to equation, and you convert this to equation. So you see this, sorry, I don't verify que I share, no? Or no? Guy, answer me. Now let me see. I see the whiteboard. Okay, now I see the whiteboard. Show me the page. Okay. Not yet. You don't see the decimal?
I see it now.
Okay, cool. Okay, so I explain something. We have four constraints: x greater than or equal to 0, y greater than or equal to 0. These together represent the first quadrant, and we have these and these. So now I put together, separated by curly bracket, and you see in green color the feasible region. But this is important to determine the corner, because you need to evaluate the objective function in each corner to determine what is maximum value. Okay, in this case, also maximum. Oh, okay, let me try to make now a screenshot. A screenshot of this. Yeah, is safe where? Here, I suppose, no? Oh yeah, I have the screenshot, but this is different. This is, let me rename P2, it's problem 2. Okay, save. Okay. Close this and come back to the whiteboard. Share whiteboard. Okay, this is my whiteboard. Now, let me know if you see on our whiteboard. And let me bring the okay, let me bring first the page. What page? I suppose it's that page. Yeah, it's that page. And the screenshot where I put here. Let me see my device. Stop. Open that. Open that. I don't know. Here, there. No, I don't know where I write that. But don't worry, it's easy. Try. Ah, you go. I put in different folder. Well, okay. This is the answer for the 18. No? Okay, so you remember okay, the thing is you solving first the system of inequality that represent the constraint, and you get the feasible region. Therefore, the solution of our problem is inside the green region. In order to maximize or minimize, in this case, maximize, you evaluate the objective function, but the objective function is C equal 6x plus 7y in different corner. In different corner, for example, I start for that corner. You will see in 4,0. Es obvio que 4 times 6 es 24, ¿no? Es obvio, ¿no? A ver, el 0. Ajá, es 24. Ok. and C evaluate in the other corner here, 3,2. Is 3 times 6 is 18, plus 7 times 2 is 14, together is 32. Okay, now the C value in that point it was 24. The C value in this point was 32. The C value for the next point is 0.4. It's 28, obviously, right? Because it's 0 times 6 is 0, plus 7 times 4 is 28. C is 28. And obviously here is 0, because both are 0. And that's the maximum of this. And this is the maximum and occur at x equal 3 and y 2. End of story. Super clear? How do you feel on that part? I don't want to put a complicated thing. And Alex, yes. And Alex, you need to working problem of the linear programming and word problem with the linear programming. Any question you have, you send me. I try to help you. Okay. Continue. Clear, right? It's the next page. Next page is about matrices. Okay, matrices. No here. Stop. We go there. Chapter 4. Next page, I believe. Okay, it's this page. Page 7. There you go. Look. It's a problem 19. The problem 19 is super easy. You apply back substitution. How do you know? Because the system is expressed in echelon. So x plus 3y plus 2c equals 6, equation 1. 5y plus 5z equal 15. By the way, you can divide it by 3 if you want, and by 5, sorry, and you convert this equation in easy way is y plus c equal 3. It's equivalent. And forget about this. And c is 5. It's equation 3. Using back substitution. Es obvio que C es 5. Entonces y plus 5 es 3. Replace C for 5. Therefore y alone is negative 2. And x is x plus 3 times negative 2 plus 2 times 5 equals 6. This is minus 6. This is 10 equals 6. And 10 minus 6 is 4. Entonces we have x plus 4 equals 6. X is equal 4 minus 6 is 2. The solution then is the triple order 2, negative 2, 5. Like the option A here. Cool. Super clear? Erase or no? Let's go to the number 20. It's super easy. It's the system. Is x plus y plus c equal negative 5. This is my first equation. X minus y plus 3c equal negative 17. And finally, 2x plus 2y plus 2c equal minus 6, equation 3. So you can do that using matrix or no, because you see in the third equation, you divide by 2, whole thing, you obtain a new equation that is equivalent, of course, depending of the original. They're the same, c equal minus 3. And when you compare this and new 3 after the division by 2, and when you see this and this together, it's obvious that this is in contradiction. It's impossible because x plus y plus c o es negative 5 o es negative 10, pero not both. It's the contradiction doesn't no solution. The technical name is inconsistent, like that. Good. Well, see, everything is okay. Let's practice a little bit the row operations. Let me try to explain again in detail row operation. We have the original matrix. Is this? Okay, it's 1, negative 3, negative 5. The bar can separate the right-hand side number, 2, negative 5, 2, and 5. And 3, negative 5, again 4, and 6. Let me check it just in case. The numbers, if we copy right, yeah, I suppose yes. And you perform in this order different row operation. The first row operation you should do is multiplication by negative 2, the row 1 plus the row 2, and this new number storage in the row 2. Do you see the notation, guys? The letter, the no capital is the antique, row 1, row 2, row 3. To say now the only row gets changed is the row 2. Therefore, I copy, super easy, the row 1 and the row 3 exactly the same, because participating in the game, however, doesn't change. Now let's do it. You need to understand very, very well this idea. You multiply by negative 2. Multiply by negative 2 who? Row 1. Element by element. This, and this. And you adding with the corresponding in the row 2. And this new number, I storage, replace, deposit, in the new row 2. It's obvious that minus 2 times 1 is minus 2 plus 2 is 0. Do you follow me this idea? Minus 2 times minus 3 is positive 6. Positive 6 minus 5 is 1. Okay, now minus 2 times negative 5 is positive 10, and positive 10 plus 2 is 10, is 12, sorry. And the last number is minus 2 times 2 is negative 4, and negative 4 plus 5, 1. Boom. Done. Good. Do you understand the operations? Where's the next? We have 3 row operations in this problem. Unfortunately, this is impossible doing in the software. You need to do by hand. Another possibility is doing by the calculator, but a sophisticated calculator. So the next row operation is minus 3 times row 1 plus row 3 storage in the new row 3. And this is sequentially. You are doing this operation not on the original. No, this is history. I delete that. In my mind, this is a new matrix. Okay, so in the new matrix, I can see how the row 1 and the row 2 stay the same. This guy stays the same. Of course, participate in the operation, but change only the row 3. So now is minus 3 times 1 is minus 3 plus 3 is 0. Minus 3 times minus 3 is positive 9, and positive 9 minus 5 4. Minus 3 times minus 5 15, and 15 plus 4 is 19. Okay, and minus 3 times 2 is minus 6, plus 6 is 0. Boom. Okay, one more. Do you follow me? Everyone follow me? This operation is complicated or is easy? Say something, guy. 5R2 plus R3, storage and R3. So now I copy row 1. Okay, it's just easy to mess up. Yeah. Super. So relax, cool down, try to do your best. Okay. You make a mistake. Everyone makes mistakes super fast. So now the organization is clear. You copy. So the only row get now in the last operation, row operation, change a row 3. So I copy 1 and 2 exactly the same. Okay, I multiply by 5. Multiply by 5 who? 5 times 1 gets the people, no? 5 times 1 is 5. And 5 plus 0. 5. No, sorry. You multiply by, I make a mistake. You multiply by row 2. So you multiply, in my mind, you multiply this 5 times this. So because 0 plus 0 is 0. And you multiply 5 times 1 is 5, plus 4 is 9. And 5 times negative 5 is negative 25. It's negative. It's negative 25. Wait. 5 times 12. 5, I tried to multiply, no, it's a row 2. 5 times 12 is 60. And 60 plus 19 is 79. And 5 times 1 is 5, plus 0 is 5. And it's the final answer. Que es the option C in the handout. Okay. Entonces, no question. So the row operations indicated in the problem. In the real life, no. In the real life, you need to discover what is the most convenient row operation. But, you know, the other is the software doing for us. Let me try 22. 22 is a big matrix, but we have only 2 operations. So the matrix is 1, 1, negative 1, 1, 3, 0, negative 5, 1, negative 2, and 0. Let me check and see I'm doing well or not. 2, 0, negative 3, negative 4, and 3. Negative 5, 1, 0, 5, negative 4. Be careful if you copy wrong something, your answer is incorrect. Okay, so now this matrix dimension is 4 by 5, 4 row, 5 column. I need to perform that row operation that is minus 3 R1 plus R2 store in R3, sorry, R3, 3, not 2. R3 storage in R3. So basically the only row get changed is the row 3. Therefore, in this step, everything stays the same except the row 3. 1, 1, negative 1, 1, 3, 0, negative 5, 1, negative 2, 0. I skip the row 3 because I know I change the number. Here I copy row 4. Entonces now you multiply by negative 3 who? Negative 3 times row 1, que es 1, es negative 3, negative 3, negative 3, negative 3, plus who? Negative 3, plus 2, es negative 3, ¿no? Es negative 3, yeah, es negative 1, es negative 1. Where come from negative 1? Let me try to understand better. Negative 3 times 1 is negative 3, negative 3 plus 2 is negative 1. Negative 3 times 1 is negative 3 again. Entonces negative 3 plus 0 is negative 3. Okay, now negative 3 times negative 1 is positive 3. And positive 3 and negative 3 is 0. And finally, no. We need 2 more digits. Negative 3 times 1 is negative 3. And negative 3 minus 4 is negative 7. No? Negative 7. And the last one is negative 3 times 3 is 9. Negative 9. No? Negative 9. And negative 9 plus 3 is 6. Minus 6. Wow. Another way to organize this idea is you copy like that. Minus 3 R1 plus R3 equal R3. And you copy minus 3, minus 3, minus 3, minus 3, 4 times. 4 times or 5 times. And you multiply by the row 1, que es 1, 1, negative 1, 1 and 3. Plus the corresponding value, at least it's more visual, no? The R3, que es 2, is 0. So I copy that. 2, 0, minus 3, minus 4, and 3. Let's check it. This is negative 1, get this. This is negative 3. Next, this is 0 because it's positive 3 minus 3. This is negative 7. And this is 9. Let me see, I make a mistake maybe, no? It's minus 3 times 3 plus 3. Is 9, negative 9. And negative 4? No. And negative 6. Negative 6. Guess this. Okay. Either way, the way you prefer. Let's do one more operation. Fortunately, okay, is 5 times. This is factor. A row operation is from one factor can multiply one specific row, can working like a pivot. And you're adding another row arbitrary and storing the same row. So this number 4 is coincident always. Now the only row change is number 4. So I copy 1, 2, and 3 exactly the same. I don't touch. Now it's a moment. Multiply 5. 5 times 1 is 5. Minus 5 is 0. 5 times 1 again is 5. And 5 plus 1 is 6. I multiply again 5 times negative 1 is negative 5. And negative 5 plus 0 is negative 5. And 5 times 1 again is positive 5. And positive 5 is positive 10. And 5 times 3 is 15. And 15 minus 4 is 11. Boom. Here's the final answer que corresponde again with the option C. And the handout. You compare. There you go. Your question. I know it's too long. No, I know it's too long, but it's not hard. If you organize very well your work, you have no problem. Okay? You have no problem. Now, let me try next page. It is, I don't know. Well, let me bring, I suppose it's this. This, let me bring the whiteboard, this and this. Okay, 23. Yeah, 23. Forget about this for a moment. Okay, let's focus on 23. Okay, so definitely we are doing this using the software, GeoGebra. You have the system, you set up the matrix associated with the system, augment the matrix, of course. Okay, -2, -1, -6. The line vertical separated right hand side 77, -7, 0, 3, -29. We have 0, 9, 1, and 72. Be careful, guys, because some variable is missing, no? Okay, in the first equation, nothing is missing, but in the second, Y is missing, and the third one, the C is missing, right? Okay, now I am ready to put in the software. Let me try to open. I don't open that. I open GeoGebra. There we go. Let me share with you and explain in detail everything. GeoGebra Classic. Do you see that? And when you open GeoGebra the first time, you see or no? Yes or no? Answer me, please. Okay. You press these 3 lines, horizontal line, and you select view. In the view, remember, I delete the graphic part because this is not my problem. Algebra stays the same, CAS and spreadsheet. That's the only thing we need. You can put in different width according to your necessity. And you type in the matrix. -2, let me use my keyboard. -2, top, -1, top, -6, everything is negative. Wow, top, -77. Enter. This is my first equation. -7, top, 0, top, 3, negative 29. Enter. Last equation, 0, 9, 1, and 72. Okay, this is my array of number. I select, you click in the mouse, left click in the mouse, press now right click, you create matrix. That's the only thing, it's the only mathematical object we are using. Okay, you rename or no, it doesn't matter, I don't care. You put here reduce row echelon in CAS. Reduce it. We don't finish to typing immediately you see of the matrix N1. Okay, present it. Wow, and this is the answer. And in the answer you see clear like water. This is super easy, straightforward case. And we you see the identity matrix dimension 3, 1, 1, 1. Therefore, X is 8, Y 7, and Z is 9. But the conclusion is this system have unique solution, only one. And the solution is the triple order, A, 7, 9. Any question? No problem. Option B. Okay. I don't want to come back again to the whiteboard. So we're solving everything. Well, yeah, some moment I need to come back. But okay, let me solve this. Do you follow me? I can erase or no? You don't need to erase. You type in, for example, in the example, yeah, I follow. In the example 24, just the next example, the matrix associated is obvious, okay, is 8 minus 7, B. I suppose you know perfectly write the system as a matrix 4 minus 122. This is my first equation. My second equation, we are doing 24 problem, guys. Minus 40, 5 positive, negative 15, and 610. This is very interesting problem. 3 equation, 3 unknown. I have no idea what's going on. No surprise. Negative 14, no 14, 14. 6 positive, and negative 224. Exactly the same. I select, I create a matrix using this array of number. Okay, matrix default is called M2. Now apply the famous reduce the row echelon form. Now matrix M2. Boom, and now surprise. And this surprise, I want to copy. In the whiteboard, yeah, explain the interpretation. Okay. Okay, let me try. So far, no problem. So you need to be aware to face any situation. Now, what is the interpretation then? I come back. Whiteboard. Okay, so far it's good. Okay, we are doing number 24 problem. And 24 problem. We get the matrix like that. So the matrix original in 24 was 8, negative 7, 3, minus 122 minus 40 35 minus 15 610. This is exactly typing in the GeoGebra, no? Now using the command, oh sorry. Now, ¿lista? Okay. Now, using the command, yeah, reduce the row echelon form, RREF. We get this answer. Wow. Is 1 minus 7 over 8, 3 over 8, fraction, 61 minus 61 over 4. And the rest is 0. Wow, 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 wow. What mean that? That mean that the equation 2 and the equation 3 are depending of the equation 1. Therefore, we can delete. This is not important information. And you say, wow, I don't see that. Well, yes, you multiply the equation 1 by 5. By 5, no, by negative 5. 1 by 1, you get the coefficients in the second. And if you multiply the equation 1 by 2, 1 by 1, you get the equation 3. But at the beginning, I don't see. But this is the beauty of that elimination process. Discover that the equation 2 and the equation 3 are dependent and eliminate in the solution. Okay, now analysis. What is the solution? The solution, then I try to find always the identity matrix, but in this case we have only 1, 1. So that means that this identity matrix is dimension 1. Que es just scalar 1. Si es identity matrix dimension 2, bueno, entonces es 1, 1, 0, 0, and so on, ¿no? But in this case, no. Entonces, this is the only variable que es non-free. Y and Z are free. This is the free variable. Okay. This is extra block que represent the free variable. Okay, entonces it's easy. You write the equation 1 like that. You isolate always the non-free variable que es x as a function of the free variable. Because free variable is any real number. Negative 61 over 4 plus 7 over 8 when you move into the other side, y, plus no, minus 3 over 8 z. Entonces you declare, for example, and either way, you declare like that. This is the solution is the triple order in 3-dimensional space, such that x is equal to that guy. I want to copy again. This is plus, and this is minus. And y and z are any real number. So you try to interpret geometrically this solution is a plane. It's a plane because we have two free variables. Therefore, the dimension of this space is 2. Okay, it's a plane on the 3-dimensional space because we have two free variables. Do you understand very well? This is the question 24. Yeah, 24. I get that. Okay, beautiful. Now let's move on to the question 25. 25. Question 25 is similar. Because I want to skip that, guys, because I want to finish today the GeoGebra part, at least in this part. In other part, no. But in this part, it's the same routine. So in 25, the matrix is 1, 2, 1, -1, 0, 5, 3, 1, 1, line, -2, 1, and 26. So now again, you apply the famous reducer row echelon form in GeoGebra, of course. Not necessarily GeoGebra is the only one software. There are many software. And okay, I like this. It's more professional, you know. The answer is 1, 0, 0, 0, 1, 0, 0, 0, 1, and after the line we have 0, 5, and 1. Okay, this is a typical format. When you see this, the identity matrix, dimension 3, and we have no extra block that represent the free variable. It's obvious that you have unique solution as the triple order 0, 5, 1. Because X is that value, Y is that value, and Z is that value. Cool? That was 25. 26 is a little bit more complicated. A little bit more complicated, but not too much. Look. Okay, the thing is that part is not complicated. You need to memorize the rule, of course, and it's too long. Entonces everything is long, is very, very probably que we make a mistake. It's the only disadvantage, but it's not hard. Okay, 26 now, no? 26. We did 24, 25, now 26. 26. The matrix is like that. It's a big 5, 2, and 0. Because 3 equation. It's 5, 2, 0. 1, -1, 0. 0, 1, 1, 0, -1, 1. Because this problem contains 4 variables. This is X, this is Y, this is Z, this is W. In the right hand side, we have 137. Okay. Okay, entonces we expect the intuition, we expect no one solution, because to be at least once a unique solution, the matrix must be determinate. So we have the same amount of equation and the same amount of unknown. And under the supposition that the equations are linear dependent, it's obvious because we have 4 variables. Number of variables is 4. And number of equations is 3, no? So now you're subtracting is 1. So under the supposition that the equations are linear independent, the dimension of the solution object is 1, to say it's a line. Okay, it's under the supposition that they are independent. See, at least one is independent, to say more is a plane or something. Okay, to say don't expect unique solution. We need 4 equations linear independent. And when you're subtracting a 0, and 0 is a point, so dimension of the point is equal 0, because the point is one object that have no dimension, no length, no width, no height, no nothing. Okay? Just detecting automatically without do anything, okay, we have infinite many solutions. See, we have infinity many solutions. We expect free variable. How many free variables? I have no idea. I put in GeoGebra, I apply reducer row echelon form, and you get this answer. Look at that. I skip that part because you know very well. And you verify. Guys, I want, can the test, you are doing the work in GeoGebra and you make a screenshot and you attach to the test. Okay. Okay. Unbelievable, the last equation stays the same. And so now this is a crucial moment. Again, this is X, this is Y, this is Z, this is W. So in order to recognize immediately what is the non-free variable, you try to discover the identity matrix. Okay? It's so big as this. This is identity matrix dimension 2. Therefore, X and Y are non-free variable. And also I see extra block like that. Where discrimination, the last one, and like that, using different color. Because there's another thing is extra block. Okay, that indicates us que C and W are free variable. Okay, the discrimination, see if free or not free, depending on the identity matrix. Well, so you're right. The non-free as a function of the free. The first equation is X alone is equal minus 3 over 7. I copy the right-hand side number. Minus no plus 2 over 7W. I put X as a function of W or Z. I don't know, depending on the equation. But Z is missing in the first and the second. Y alone is equal to 22 over 7 minus, in this case, we gotta move 10 over 7 to the right-hand side, W. And, oh, no, I make a mistake, coño. Look, sorry. Look, this is the, no, this is wrong. This is the identity matrix, dimension 3. Wow, you try to take the bigger. So the conclusion is wrong. X, Y, and Z are non-free, and W is the only one case. In one moment I realize, because obviously the C is equal 7 minus W. Okay, and you're right. The solution, there are two different ways to express the solution is look. Is the X, Y, Z, W, que es one space in 4 dimensions, que this space in 4 dimensions is impossible to do a sketch by physically, no interpretation, but algebraically, yes. And you copy X equals something. This something is this expression. I don't want to copy again. Comma, Y equal another something, que es this something. Comma, C equals something, another expression, que es this. And comma, W are any real number, because it's free. This is one possibility to write. Another possibility is you type in like a 4 order, so X, comma, Y, comma, Z, comma, W. And you copy this expression here, this expression here, this expression here, and W stays there. And everyone understand the word que W es the free verb. Cool? No problema. No problema. Answer me. So I finish this page. I follow. Okay. 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 I follow. Okay. Let's move on to the next page. Oh, next page is determinant. 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 I want to compute this determinant by hand first. Curiosity. And after I want to explain in the software. So we're doing 27 questions. Let's compute this determinant. Remember, determinant is different to matrix. Look like similar, but no, because the matrix is an array of number. A determinant is also an array, but it's a square, and you associate using one specific formula with the one number. So the answer is one number. When I compute that, the answer is one number. Bam. And the matrix never is a number. It's a you transform the matrix, but no number. So they are a function que associate with this, with the specific formula. I want to explain now. This formula is a cofactor formula. Cofactor formula. That part I don't explain in the lecture, but I want to explain. It's easy. And after you can solve in GeoGebra. I want to explain now. Look, the cofactor formula you navigate for any row or any column. This is the beauty of the determinant. And the matrix, no, in the matrix we work in row operation, row operation, row operation. And in determinant, no. In determinant, you're working as a row operation and column operation if you want. But I prefer row operation because it's the traditional. Suppose I navigate with row 1, is this. And you copy one by one. You copy one multiplication by something. And this something is the minor. What is the minor? The minor is one new determinant gets formed when you delete mentally in your mind this row and this column. Because I am using that number, no? It says 4, -1, 5, 5. Okay? Okay, there are several names. Cofactor. What is the cofactor? Cofactor is one formula. And inside the formula, we get minors. What is the minors? The minor is when you navigate and you take this number first, get 1, you delete mentally this row and this column. And you get a new determinant that's called minor. Minor, this case, the minor 1, 1. Minor 1, 1, because it's associated with the element in the row 1, column 1, 1, 1. And the sign is alternating, plus, minus, plus, minus, plus, minus. The next is minus. Minus who? Minus 1, because this 1, you change the sign. Minus. Multiplication by new determinant, 2 by 2, que es easy. Gets formed when you delete mentally. You are doing this, and this. And we have now -2, -1, -3, and +5. Now, this is the minor 1, 2. Why 1, 2? Because you moving through the row 1, but we have in the column 2. Now we finish. No, we need to do the last one. Get this. Because we completed one row. Doesn't matter if you select row 1, row 2, row 3, or column 1, column 2, column 3. Of course, the array is different, but the answer, unbelievable, is true. It's the same. So you put negative 2, remember the sign is alternating, but you see you have positive, but it's positive negative because it's negative 2. And now you multiply by minor 1, 3, no? Okay, minor 1, 3 is formed when you delete mentally this and this, and stay alive, minus 2, 4, minus 3, 5. Okay, now the rest is pretty easy because you know the formula for the 2 by 2 gets super elementary. You multiply like that, don't change the sign, and you multiply by like that, change the sign. So this is 20, this one is invisible. 20 plus 5. Why plus, Professor? Because 5 times negative 1 is negative 5, and an extra negative that you put in the diagonal that goes up is positive. Minus this negative 1. A multiplication this and this again, no change the sign. A multiplication this and this, change the sign. This is minus 10 because negative 2. 5 positive is negative 10, no? But here in this diagonal we have 3 negative, 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 negative. This is negative, negative 3. Minus 2. A multiplication this and this. Okay, it's minus 10, obviously, right? A multiplication this and this. Don't forget to change the sign. This is 12. Okay, we almost finished. We have 25. This guy is 25. Minus, this is negative 13. 1 negative positive 13. And this is, let me see, 2. And negative 2 is negative 4. So we have 34, no? 34 because it's 34. Yeah, this is 25, 13, 8, 38 minus 4 is 34. Yeah, it's the answer. Do you follow me? But don't worry too much. Don't worry too much because I want to explain how you are doing this in 5 seconds in GeoGebra. Okay, let me share GeoGebra. Okay. Okay, suppose this example. Do you see GeoGebra? Yes or no?
Yes.
1, 1, negative 2, enter, it's a square, minus 2, 4, minus 1, negative 3, minus 3, 5, 5. They copy well. Let me double check. I select, compare to the matrix temporary. This is matrix 3. Let me check it out. The number 1, negative 1, negative 4, negative 1, negative 3, 5, 5. Cool. And you type in CAS, determinant. Determinant. Look, when you don't finish to type in, you see the determinant matrix. And you put inside the matrix 3, M3. You press enter, bang, and the answer is 34. Cool? Okay, so we are doing exactly the same always. You get that? Okay, let's do a couple by hand because it's super easy. Look at that. Do you see whiteboard? Yes or no? Do you see now whiteboard? I don't see. Let me try again. Now, you see or no? Okay, okay. Okay, 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 okay. Let's do in 29 and 28 and 29. 28 is 300 964 798, and we need to compute this determinant. And the professor is explained I can select any row or any column. So I take advantage the row 1 because in the row 1 we have only one guys. The other cofactor is 0. Actually, it's equivalent to say 3 times. And the minor associated with this is 6498. Yes or no? And the rest, you don't need to continue walking because it's 0 is 0. Okay, now already is 3 times multiplication 48 minus multiplication 36 is 12. And 3 times 12 is 36. Boom. That was 34. And 29 is very, very interesting because you don't need to do anything. If you recognize one property of the determinant, and when you see the row 1, que es 1, 2, 3, and the row 3, que es 1, 2, 3, is the same. And when this situation happens, when the 2 rows are equal, or when the 2 columns are equal, the determinant is equal to 0. Okay? 0. Okay, let me explain 30. Okay, 30 is, you know, very, 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 very long. But I try to simplification. And you verify on your own computer. Oh, no, exactly. And it's the Kramer rule. And remember, I want to recall Kramer rule. Kramer rule is you compute determinant D and X is dx over D and Y is dy over D. It's another approach to solve the system using determinant, no matrix determinant. And C is equal dz over D. And some people I found in my life can lie this way. I don't lie, but some people prefer that way. Okay, I respect. You know? So now, first of all, we determine the D. D is the determinant, guy, formed by the coefficients in front of the variable. Fi, 0, y is missing in the first equation, 9. That's it, 3 by 3. The right-hand side is not included inside the game now. Minus 6, 3, minus 8, 2, minus 6, and 0. And we're using GeoGebra. I want to skip that part. And the answer is 30. You can verify if you want. What about dx? Dx is similar. The only thing you should do is replace only the column of the x by the right-hand side number. So we have 52, negative 42, negative 14, and the rest stay the same. I don't touch. I compare it with the GeoGebra, it's too long, 150. dy. It's easy, the organization. It's long, the computation. F5, negative 6 to 52 minus 42. The thing is, I replace the Y column for the right-hand side number, no? E negative 14. The other stays the same. And the answer, when you compute this in GeoGebra, is 120. And this Z. And the test, one question, I want that you are doing in that way. So you are doing in another way, because we studied 3 different ways for solving the system, no? Inverse symmetry, echelon, reduced echelon form, and Cramer rule. To say one question in the test is mandatory doing, so you want to get the credit. No, you are doing another way, 0. And this is, well, 5 minus 6 to 0, 3 minus 6, and you replace 52 minus 42 and negative 14. And the answer is this is 90. Now conclusion, x is equal 150 over 30, get 5. Y is equal 120 over 30, get 4. And C is equal 90 over 30, get 3. Now, the solution for the system, a unique solution, only one, the triple order 5, 4, 3. Cramer rule. Okay. Look like easy. No, it's long. It's easy, the organization, the long. Well, the long, fortunately, we are doing the software. Definitely. Okay. Okay, let me try now to explain the question 31 and 32. It's a little bit sophisticated. And the majority of the students make mistakes in these questions because they don't understand very well the idea behind this. Let me show you. This is using property of the determinant I want to explain now. But I want to explain specifically in this example. Suppose one determinant is given. Question 31st. And unfortunately, we cannot use in the GeoGebra because it's a letter. X, Y, C, UBW, 1, minus 3, minus 1. And the problem say that the answer of this determinant, I don't know how you find that at 38. Yeah, I need to find another determinant that is similar. Using the same variable. Actually, it's no variable, it's a number. But the problem is that I don't know exactly what is this number. But I try to discover the idea. I need to compute this. Boom, question mark, I don't know. But I see some partners, some regularity. And the regular is clear. So you take the column 1. Column 1. Who is the column 1? This is the column 1. Plus a column 3. Who is the column 3? Well, column 1 is this, okay, put in green color. Or is this. I propose you working on this to convert to this, because this is information is given, no? And the column 3 is this. This is the column 1, and this is the column 3. So you are doing this column operation, que es impossible doing in matrix, but in determinant, yes, you can manipulate with the column. Es obvio que after this operation, this column stay the same, this column stay the same. However, the column que change is the column 3, que es addition. So you adding x plus C minus X. It's obvious that X is cancelled and it stays Z. Likewise, and the second is U plus W minus U is W. And the third is 1 minus 2, que es negative 1. This is the answer, que 38, because this is exactly the same as the original given determinant. And when you perform a property, you need to know row operation or column operation, the value of the determinant stay the same, doesn't change. Unbelievable, but it's true. Okay? You get the idea? Doesn't matter. Okay, you need to find the proper column operation or row operation. Let's see in the next example, it's a little bit more complicated. A little bit, not too much. Not too much. Okay. This example, again, is giving one determinant. I have no idea what is the number inside X, Y, Z, U, B, W, similar. 1, but different, minus 1, minus 3, and this is equal 146. Okay. Yeah, I need to compute another determinant is similar, well, not too much. Three U minus 1, 3B plus 1, and 3W plus 3. And here 1, negative 1, and negative 3. I need to compute this. Question mark. Well, the only similar I see is this row and this row. So I need to do something to working on this to go in this direction, similar to this. I don't know if it's equal. No, definitely I believe que no. So now, for example, I see because you are doing this row operation, row 2 plus row 3 stores and row 2, so you adding this row and this row together. It's obvious que that part cancel out. Bam, 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 bam. I saw that. And stores and row 2. So now row 1 no, stay the same. Row 2 change to 3U, 3B, and 3W. And row 3, well, participate, but it doesn't change. The only row we change is row 2. So you need to know another property. Another property is wow, when you multiply any row or any column by a number, the value of the determinant is also multiplied by this number. So these 3 I saw here, 3, 3, and 3, you factor out. You put outside like a common factor. This is not valid in matrix, but it's valid in the determinant. Because a matrix is different. A matrix, when you multiply one matrix times one scalar, you multiply every element inside the matrix by this. And determinant, no. And determinant, you multiply outside the value. You multiply the row or the column that you select that you prefer. So in this case, we are doing backward. We are factor out 3. Okay, and this 3 is important in the computation of the final answer. Now I propose you are now multiplication. Let's do in this row operation now. I know the row operation doesn't change. I multiply by -3, row 3, plus row 1 and storage and row 1. Basically, you multiply by -3 this row plus this row and stores the result inside the place of the row 1. It's doing. This stays the same. I participate, but no, doesn't change. This stays the same. But this change is -3 times 1 is -3 plus 3 is 0. Is x minus 3 times -1 plus 3 minus 3 is 0 is y alone. And -3 times -3 plus the 8 and -8 together is 0. Wow. Now, don't forget these 3. Okay, factor out. Please don't forget. This stay here. Because I'm working inside the determinant. And we compare. And we compare who? We compare the result that we have so far and the region. This is equivalent 146. And now multiplication 3 times 146. And the answer 438. Like the option A. Of course, I don't want to complicate too much this. It's just similar problem in the test. But it's a property you see. I summarize the property. I can say basically 2 property or 3 property. When you have 2 equal row, the determinant is 0. When you multiply 1 entire row or column by a factor, this is equivalent to multiply the entire determinant by this number. It's exactly the same I do here. 3. It's common factor to get factor out. I multiply. And of course, the classical row operation or column operation, okay, when you are doing those unbelievable, this is magic. The value of the determinant stay the same. Stay the same. Stay the same. This is magic. Let's move to the question 33, que es super easy. It's long. I know that everything is long here, but it's easy. See, we have no time to finish. To the Monday, we finish a little bit because it's a small part and start the last chapter. No? But it's okay. I suppose that we can do something. Okay, basically is multiplication of the matrix. Is 3, 6, -8, 9, -9, sorry, 4, -2, multiplication of another matrix is -3, 8, -6, -3, 7, -2, -2, -3, -2. Okay, first of all, we analyze the dimension because you know that the multiplication of the matrix is piggy and see don't match the dimension, thus it's impossible, it's totally undefined. But the dimension for the first matrix is 2 by 3, 2 row, 3 column. And the dimension of the second matrix, it's a square, it's 3 by 3. Therefore, this number and this number is okay, it's the same, matching. Now the multiplication is possible, do it. And the new matrix, of course, is a matrix 2 by 3. Exactly the same of the original, by coincidence. We need to find 6 numbers. 1, 2, 3, 4, 5, and 6 numbers. Let me explain in GeoGebra. Super easy, super clear. Super easy. Let me explain. Let me share another window. You let me know if you see or not. Do you see or not? No? I can see. I want to delete everything. Okay, so I copy my famous matrix. Guys, full attention. Because if you change one number or you change one sign, you screw up everything. We get different result out. And we are in big trouble. This is -8, no? Delete -8. Okay. Now on -9, +4, and -2. Well, this is my first matrix. If you want, you create right now. Create matrix. Boom, and the name is N1. In another place, you want, you type in the second, -3, 8, -6, enter, -3, 7, wrong, -3, 7, stop, no enter, tap to change the column, -2, now enter, yes, and this is -2, no sir, clear. Es -2, no? -2, -2, -2. Tap, -3, tap, and -2. Enter. Bam! And I doing the creation of the second matrix. Bam! And I have in my hand N1 and M2. As you go to the cast, okay, the cast allows us to do any operations with the matrix. And you put N1 time, and time you know is after. Time is the shift and the key 8, N2. Center to perform the operation. Bang! And this is the answer. It's -11, 90, -14, 19, -38, and 50. It's exactly the same, the option D and the handout. Cool? Let me come back to the whiteboard. Whiteboard. Oh. Do you see whiteboard?
Yes, yes.
Okay, let me erase this. No. All right. We have another page here. Look at that. We did 33, no? 33. Look at the answer is this. And 33, the answer is this. And 34. 34, 33, 34. Oh, look at that. 34 is very, 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 very interesting. Maybe you expect something in the test like that. Look, I have 2, -8, 1, 6, 0, 1. This is 3 by 2 dimension. The to determine dimension is important in the multiplication. And this is -3, 2, 1, -1, 6, 1. And it's the same dimension as 3 by 2, but do not matching this number and this number, it's different. Now, what is the conclusion? No define. It's impossible. And if you try to do in GeoGebra, say clear, mismatch dimension. No problem. You cannot do anything. Okay. Let's do a couple of problems of the. Entonces I suppose que the question 37 and 38 we are doing Monday. Okay, stay the same due date of the test because we are doing this in 10 minutes. Let me try to do the inverse function. The inverse function. The inverse function. The inverse function. The inverse matrix, no function. Sorry. Okay. Suppose it's given 1, 1, 4, -1. One matrix given. And my goal is compute. I want to do by hand and double checking with the GeoGebra, and that's it for today. I don't know, so you have time or not. First of all, step 1, we compute determinant. So you determine, you change the square bracket to the vertical line, get determinant, and we compute that. And remember the rule, you multiply this number and this number, don't change the sign. You multiply this number and this number, change the sign. It will be 4 times 1 and 4 plus double negative positive 5 and 9. Wow, and 9. And 9. So the formula, let me copy the formula for inverse function. The formula is, suppose that we have one matrix like that, A matrix is equal A, B, C, D. You compute it first, and the first step, the determinant, and you divide 1 over determinant, is A times D minus B times C. Okay, in our example was 9. The answer was 9. And you now permutation a little bit A and D, D here, A here, with the same sign, and B and C stay the same but change the sign. This is the formula to compute the inverse and 2 by 2. And 3 by 3 is more complicated. Let's see Monday. Now, I discovered que 9 is this number. Actually, my inverse would be 1 over 9, and you copy 1, 4 here, and you copy 1, -5. You see that? Okay, 1 and 4 interchange. 1 and 5 stay the same, but change the sign. Actually, more clear, much better is 1 over 9, because you multiply this times this. And this is different, you know, to determine. When you multiply F scalar times matrix, you multiply each entry, each element by this. 1 over 9, -5 over 9, and 4 over 9. Okay, is the option C. Is the option C. That one. Boom. One more, and that's it. And we waiting 37 and 38 to the last one, to the Monday. Wait. That's easy. Is the matrix given in a 36 is 0, 1, -5. Okay. Number 1, compute the determinant. 0, 1, -5. And you compute the determinant. Okay, 0, 0, 0, 0, 0, positive. But 0 have no sign, 0, 0. And this negative. Es obvio que doble negative become positive, entonces 5. The answer is 5. Now interchange. This is the A matrix, the original. However, the inverse matrix is 1 over 5. And you interchange -5, 0, and 1 negative and 5 positive. Now, when you divide inside 1 by 1, we have -1, -1/5, 1 positive, and 0. Boom, and the option A is the answer. Cool. I suppose we have time to finish everything. Guys, too much, eh? Too long, eh? But this is a review. Say something, say something. Say something. Continue, okay, cool. Continue. It's a spirit I want to hear. Keep going, Professor. Okay, let's do it. This is super easy. Look, let me show you. But you solve the system one more time, but using inverse matrix method. And what is the formula? The formula is capital X, que es a vector formed by little x, little y, little z. No, let me change this to C, classical C, we always working. Is equal the inverse symmetry of the original multiplication by B. Inverse symmetry. So now, who is A? A is the coefficient, is a square matrix, is the coefficient in front. The variable is 1, 2, 3, 1, 1, 1, 1, 1, 0, and negative 2. This is my mate. And who is B? Bueno, B is a vector, column vector, que is 4, minus 5, and minus 6. Okay, this is 3 by 3, square matrix, nice, it's invertible, and this is 3 by 1. And now multiplication. Multiplication who? Multiplication, the inverse symmetry, that formula. Time B. Let's do it right now in GeoGebra. Let's do it. Okay. Do you see GeoGebra? Let me erase everything to don't contaminate this problem. I copy A. Okay, A is in any place, guys. One. Tap. Enter. 1, 1, 1. Wow. 1, 0, and negative 2, no? I did well? Yeah, I guess so, right? This is A. Let me create the matrix right now. Matrix. Let me rename. Not necessary, but I want to do. Because I want to call A. Bam. Let me check the number. Yes, no problem. I type in B. Any place, guys, it doesn't matter. Case 4. Negative 5. And negative 6. I make a mistake, coño. Negative 4. Negative 5. Let me select using the mouse directly. Negative 6. Okay. Okay. But I screw up everything, no? Here. All right, let me see. Carajo. This is 1, right? But change automatically, you know? Okay, 0 and negative. Cool. Now I select and create vectors.
You forgot the negative 4.
Oh, I forgot. Yes. Thank you. Es 1, no?
Yes.
Excellent. So now I create another. I want to rename like a B. Okay, now ready. I go to the cast. In cast you put invert. I don't know, invert. Invert is the name. Wow, I don't like this name. Invert of what? Of matrix. What matrix? A matrix. And this is the inverse matrix. Well, okay, by curiosity, after we are doing the multiplication this time, the original A, and let's see what happens. But no now. I want to now copy again, invert of the matrix N1 again. N1, no, A, sorry. Capital A. Now, after the parenthesis, U time time B. Capital B. And press enter. Boom! And this is the answer. The answer, give me a column vector. and the column by to say que x is equal minus 22, y is equal positive 25, and c is equal minus 8, que corresponde with the option A in the handout. And Monday, I want to repeat this, plus another problem, and we start a new chapter. Okay, guys? Just in case you continue working in the test online and the test on paper, and submit December 5th, no? Okay, the due date. Okay, cool, nice. How do you feel? Strong? Good. You're the best in Miami-Dade College. I told you. Bueno, this student. Camila, good. This is Camila. Camila, I want that you are doing A in this test, okay? I cannot help in the test. I can help in the homework. Any homework? Okay. I can help. And the test, no. This is your test, not my test. I passed this class, right? Okay, guys. Bye-bye. See you.